Hello everyone, my name is Amparo López and I am full professor at Hydraulic and Environmental Engineering Department at Universitat Politécnica de Valencia. Today we will speak about what is a hydraulic model. When we finish our presentation, we will be able to understand the need of modeling in the hydraulic topics and fields. We will be able to understand the applications of hydraulics model and to recognize the different sorts of hydraulic models. So we will be speaking about the need of modeling, the hydraulic engineering model at a glance, hydraulic modeling, and then hydraulic models, applications, and finally the conclusions. So why do we need to model? Because the reality is complex. In general, engineering needs models to take decisions based on tools who represent reality and be useful with the outputs of the models. But models need people behind to be reliable and data to have good representations. So the model is a simplified schematic representation of real world. So when we simplify and when we make a scheme, then we have to take decisions to understand what's happening. So models are used to help engineers, science, and decision makers to determine what's happening in many things and to predict what will happen in the future. This is in general, but what is hydraulic engineering and why do we need models in hydraulic engineering? Hydraulic engineering deals with liquids, the motion and the interaction with components and structures. So the science of hydraulics then works with the real liquids in engineering fields, although it's very related to physical and real laws derived from hydromechanics for ideal liquids, sometimes in mixture with gases. So hydraulic model will deal with a modeling, the definition of a representation of reality using hydraulics, relate to the description of physical or mathematical simulation of a prototype of a failed situation, dealing with hydraulic models, with velocity, with pressure, and with transport of any aspect happening in liquids. We have several sorts of hydraulic models. The first one is physical. Physical model represents a physical concept whose real characteristics have a real resemblance to physical attributes that want to be represented. It's some sort of scaling the problem. So we will represent the problem with different dimensions, but with physical device. So we need this physical device and the points to take measurements inside the physical model. On the other hand, we have the mathematical model. Mathematical model is the set of differential or algebraical equations representing the action that we want to model. So when we solve a mathematical model by a computer, then we have a computational model in which we solve these equations in a system with relevant data for the specific site. We can also have numerical model. We solve sometimes numerical and computational are similar, in which we solve these equations by a numerical technique based in some sort of prototype situation to get or real case velocities, pressures, and other aspects related to the hydraulic modeling solving these equations. We can use this sort of model. Hydraulic modeling is very open. We can use it for closed conduct flows in terms of pressurized networks. We can use them in free surface systems, in open channel systems in which we determine velocities and free surface. We can use this in storm drainage systems for urban waters, for sewerage and so. We can use them for shallow water equations in terms of estuaries and ports and coastal waters with two-dimensional systems solving the equations. Or we can use it in coastal and deeper parts near structures near the coast, or even in hydraulic real structures in breeze, dam, rivers, and so on. And there are many other applications of hydraulic model even when we consider other modern applications, when we consider transport equations and we calculate the concentration of several species trained in terms of hydraulic movement. So models are a tool to take decisions in terms of hydraulic model for hydraulic engineering, representing reality. And they are needed to be used to take this decision with tools that help us as some sort of numerical laboratory to take our decisions about velocities, pressures, and other hydraulic magnitudes. We can have physical, mathematical, numerical, and computationals, and they have many applications in hydraulic aspects and even in social and other economic aspects in environmental issues. This is all I wanted to tell you. I hope it was interesting. Thank you very much indeed.